All right, next concept is to identify horizontal asymptotes. We just talked about vertical asymptotes. Could the rational function, ever cross a vertical asymptote? No. Horizontals are a little different. We say that the horizontal line y equals b is a horizontal asymptote of the rational function if the y values approach b as x either goes to positive or negative infinity. So if you look way out to the right or way out to the left, the y values will go down to this value b. Or way out to the left as x goes to negative infinity, the y value approaches b. Okay, the graph can cross a horizontal asymptote. It doesn't have to, but it can. If you look at the first example graph there, do you see that it crosses right here? It's okay. The second example, do you see that the y value gets closer and closer and closer? It oscillates less and less. That one crosses the horizontal asymptote infinitely many times. A function cannot cross a vertical asymptote, but it can cross a horizontal asymptote. How do you find those horizontal asymptotes? There are 3 rules. With a vertical asymptote, you wanted to factor everything, right? How did we find the vertical? Factored everything, canceled common factors, those were your holes. Everything left in the denominator produced a vertical asymptote. Could produce. Okay, for horizontal, you want everything multiplied out. You want to be able to find the power function in the numerator and the denominator. All you're looking for is the degree of the numerator and the degree of the denominator. That's kind of why we did this before we started the class, right? Find the degree of the numerator, the degree of the denominator. If the degree of the numerator is smaller than the degree of the denominator, right here, we have a horizontal asymptote at y equals 0. If the degree of the numerator is the same as the degree of the denominator, we look at the ratio of the leading coefficients. The horizontal asymptote is y equals a over b. And last, if the degree of the numerator is bigger, if it's top-heavy, there's not a horizontal asymptote.
I remember someone saying stuff like BO,
Yeah, there's a lot. I don't know. I just remember if it's top-heavy, there's no horizontal asymptote. Okay, 3 rules for horizontal asymptote. If the top is smaller, it's y equals 0. If they're the same, it's the ratio of the leading coefficients. If the top is bigger, there's not a horizontal asymptote. Okay, a note. If the top is 1 bigger than the bottom, there's what's called a slant or an oblique asymptote. And we'll do an example in a second. You're going to use long division to find that slant asymptote. All right. I see so much excitement in the room. Find the horizontal asymptote. Y equals 1 over x. What's the degree of the top? 0. What's the degree of the bottom? Degree 1. The top is smaller than the bottom. That means that there is a horizontal asymptote where? At y equals 0. Since the degree of the numerator was smaller than the degree of the denominator, there's a horizontal asymptote at y equals 0. So when you go graph, y equals 0 is a horizontal asymptote. Let's go back and review for just a second. Are there any holes? Can you cancel anything?
No.
There are no holes. What about vertical asymptotes? Set x equals 0. That produced a vertical asymptote. So when you graphed the vertical asymptote, it would look something like this. You agree?
We don't have to do that right now.
Not right now, but you're going to put everything together. I'm kind of trying to build you up to putting it all together. I would then go look at my graph on my calculator, and you see that it looks like this. We all there? All right, number 2. First of all, let's do what it asks you to do. Let's go find the horizontal asymptotes. Horizontal asymptotes, you want to multiply everything out, correct? You don't want it factored. So you want x plus 1 over, what is that, 2x squared plus 5x? No. Plus 6 minus 1, yes. Plus 5x minus 3. What is the degree of the numerator? 1. What is the degree of the denominator? The degree of the numerator is less than the degree of the denominator. There is a horizontal asymptote where? At y equals 0. Looking back to this one, are there any common factors? No, so there are no holes. Are there going to be any vertical asymptotes? Yes, where? X equal negative 3 and at x equals 1/2. Those are all 3 different things that I would ask you to find on a test. So to go graph it, x equals 1/2 is a vertical asymptote. X equal negative 3 is a vertical asymptote. And y equals 0 is a horizontal asymptote. And there are no holes. Do you know what that graph looks like?
Isn't it like it's either like one side or is that?
Yep. There's more pieces as you get to put together. But I'm going to tell you to go look at your calculator. Calculator does a lot. Okay, go do number 3. What's the degree of the numerator? Degree of the numerator is 2. What's the degree of the denominator? 2. The degrees are the same in the numerator and the denominator. So there is a horizontal asymptote, and it's at y equals the ratio of the leading coefficients. 4 over 1, which is y equals 4. If I were to set the denominator equal to 0, x squared plus 1 equals 0, are those real values? Nope, they're imaginary, right? So that means that there are no vertical asymptotes. If you set your factors in your denominator equal to 0 and you get i's, there's not going to be any vertical asymptotes. This function only has a horizontal asymptote. And where is it? Y equals 4. There would be a horizontal asymptote up here. Are there any common factors? No, so there are no holes. Just for giggles, let's go back up to the examples in the... Yep, wait. Just kidding. So let's go back up to the first set of examples and find our horizontal asymptotes. Looking here, what's the degree of the numerator? 0. Degree of the denominator. So there is a horizontal asymptote where? At y equals 0. Right here. On number 2, the stuff that's left, so here, y equals x minus 4 over x minus 3. What's the degree of the numerator? It was actually 2 to begin with, but the reduced form one is degree 1. Degree of the denominator on the reduced form? 1, because you had x minus 4 over x minus 3. So there is a horizontal asymptote at y equals 1 over 1, so y equals 1. There's a horizontal asymptote here. You see the function you're looking at as x minus 4 over x minus 3. Ratio of the leading coefficients is 1. Was there another one? Yep. What's the degree of the numerator? 1. Degree of the denominator. There's a horizontal asymptote where? 2 over 7. Y equal 2 over 7. Number 4. Degree of the numerator. 1. Degree of the denominator. 2. So there's a horizontal asymptote where? Y equals 0. You should be pros at finding vertical asymptotes, holes, and horizontal asymptotes. You'll need to be able to find them.